Hello, my friends. So it's Mr. Ryan. As you can tell, this is not a regular scheduled programming. Today, I am a little too tired and a little too burned out to make more videos tonight. I made some for Algebra 1. I am tired. At some point, I will make real videos for this. I don't think this year is the year. That's okay. For Unit 3 review, I still wanted to give you guys a review since I'm not with you guys today. I'm going over our super secret study sheet today. Obviously not a super secret, but I love it. I love the S's, so I'm going for it. So I have this really cool laser pointer, so I'm going to be using that to help us today. So let's talk about GCF first. Ooh, that's really cool. What the heck is that? Okay, well, anyway. Sorry, I'm learning things as we're starting this. Okay, so GCF. GCF is all about talking about our terms. Our first term is our 3x squared, and our second term is our 9x. If we talk about this, we are literally talking about what multiplies to these things. We know that 3x squared is 3 times x, and 9x is 3 times 3 times x. In common, they have a 3x. Inside my parentheses, I give my leftover stuff, which is x plus 3. I took out one of the x's here. I took out a 3, so I have a singular x left. I took out one of the 3's here, and the x, so I have a single 3 here. That is all we do to factor. We do the same thing no matter the polynomial. So here we're looking at difference of squares. Difference of squares is a factoring method, which is huge. It is a factoring method. Difference of squares is based on a very specific general notation. If we look here, we're looking at my example. It's 4x squared. 4, if you realize, is a perfect square. X squared is a perfect square. And if you look at 16, 16 is a perfect square. So that's huge. So it needs to be all perfect squares to be able to use this, hence the name difference of squares, or in our notes it's called difference of perfect squares. We have our ax being squared, so we take this and we're going to square root it for our answer, and we have a b squared, and we're going to take our 16 and square root it to get an answer. If we look here, it is ax minus b, meaning this was square rooted. So what's the square root of 4x squared? It is 2x. What is the square root of 16? It is 4. You may be asking, well, Mr. Ryan, what if I did the square root of negative 16? Because I have a negative here. We are not working with something where our negative was not given to us from the beginning. From the beginning, our negative was there, which means we are not going to be using it in our square root. So we have no i's with the difference of squares. It's just the square root of 4x squared, which is 2x. So 2x minus b being the square root of 16, which is 4. So it's 2x minus 4, and then 2x plus 4, which is part of my formula. Thank you. Now let's talk factoring. Factoring, we factor together using our M method. M method is a trinomial. We are using a trinomial here. We are given a trinomial specifically. Our general skeleton is that we multiply our ax squared times our c. If we look over here at my example, we had to take out a GCF first. We always take out the GCF first. If we look here, the first step always is our GCF. So now that I have taken out the 4, I have my trinomial ready to go for us. Beautiful. So I do x squared times negative 15. I get negative 15x squared. After that, I'm going to make my general skeleton, which is this part, which is my plus, which is underneath my a times cx squared. And parentheses on both sides, I bring down my ax squared to my first parentheses, and I bring down my negative 15 to my second parentheses at the end of it specifically. Very cool. Then we find out my chart here. We do negative 15x squared, and we're trying to add to equal to negative 2x, which is our b value here. It is very important that you realize that we are multiplying to get to negative 15x squared, and we are adding to get to negative 2x. Negative 15x is negative 5 times 3. If you didn't realize, if you tried this question on your own and you tried to put the negative with my 3x here, you'd realize that I'd get a positive 2x when I added them together, which is not what we want. That's why the 5x gets that negative. Then we're going to put them into their parentheses. It does not matter which one goes into which. From there, we take the GCF and GCF of both of these parentheses that we made. The GCF of x squared minus 5x is x. The GCF of positive 3x minus 15 is just the 3. Then we squish. We take the GCFs, we put them into their own thing, so we have x plus 3. Those are our GCFs. And then we take our matching notation, which is inside my parentheses here, and we plug them into this x minus 5. Brilliant. That is all we're doing, and that is your answer. We're done. That's it. That is what we do when we're factoring. When we're solving, obviously we solve. We'll look at that very soon. Now, last but not least, factor by grouping. Factor by grouping has a polynomial, which is 4 terms. So I have 1, 2, 3, and 4 terms. We must group the first 2 terms, so these 2 terms. And then we must group our second pair of terms, so 5x minus 10. And then we get here. It is beautiful. It is lovely. We take out the GCF. If we look here, it is the same thing that we did in our M method. How exciting. So our GCF from our first parentheses is x squared. Our GCF from our second parentheses is 5. And then we squish. We do our x squared, or GCFs, together. And then we do our x minus 2 together because they're the same. And we took our matches together. And we're done. Now let's talk solving. Solving. Factor first, then solve for x. So we have talked about 3 different ways of factoring. We've talked about factoring using our factoring method. For us, it's our M method. We've talked about factoring through square roots to factor a quadratic to solve. And then we've also talked about quadratic formula now. It is not a factoring method, it is quadratic formula. It's a formula. So this is how we solve a quadratic. So we have factoring first. We take whatever answer we get from our factoring. I'm going to use this factor by grouping question to help us here. We take this first part and we're going to make this equal to 0. And we take the second parentheses and make it equal to 0. If there was an x that I took out in the beginning here, that x would also be set to 0. If we look here, we have x plus 3 and x minus 5. We're going to solve each of them separately once we've set them both to 0. So I take the first part, x plus 3. This equals 0. When I solve for x, x is equal to negative 3. And then when I solve for x minus 5, and I solve for x, I get x is equal to 5 because I added 5 on both sides. Brilliant. We move on to square roots. Square roots, we are square rooting each side of the equation. I see that I don't have an example here. I wish I did now. Remember that when we are square rooting a variable specifically, that it can be either a negative or a positive version of that variable. So when we have, and please just try to visualize this with me, if we have x squared is equal to 4, if I'm just trying to solve for x, I would square root both sides. The square root of 4 is 2, correct? So it's x is equal to the plus or minus of 2. You can look at that on your guys' study guide though, so I'm not too worried about not having an example here. Next, last but not least, is our quadratic formula. You must identify your a, b, and c. As a reminder, your question must be in this format. It must be x squared first, then x, then your constant, which has no x variable. It must be in that format for your a, b, c to be accurate. Then you can just plug it in. And once you plug it in, all you gotta do is plug it in correctly, my friends. That's all you gotta do, and then you'll be done. Last but not least is our discriminant. This tells us how many solutions we will have and their type. I have made this question a extra credit question since I messed up in my, I think, 5th period and did not teach it yet. So I will be teaching it to them the day of the test, and I don't think that's very fair if I told everybody that that was going to be part of the test without it being extra credit. So discriminant, we take the inside of our square root, b squared minus 4ac. And we're going to plug in all of our numbers into our discriminant format. And if that number produces a greater than 0 number, meaning it's a positive number, we get 2 real solutions. If we think about that, this is the square root of my discriminant, right? So the square root of a positive number, let's say 4, gives me 2 real solutions. That checks out. That's brilliant. Then I'm looking at if my discriminant is less than 0, meaning it's negative. That means my square root, inside my square root, is a negative value. Obviously, we know that the square root of -1 is equal to what? Is equal to I, which means that there are no real solutions. There are imaginary solutions only. Then, last but not least, we are looking at our discriminant is equal to 0. This is when it's obviously equal to 0. It's not a positive or a negative. So if we were looking at our plus or minus here, think about plus or minus a 0. Can you have a -0 or a positive 0? No. 0 is just neutral, meaning plus or minus 0 is only going to be 0 ever, meaning I only get 1 solution here. Isn't that crazy? I only get 1 solution while everybody else gets 2. Well, that's the power of a plus or minus. It's brilliant. And then last reminder for my extra credit point is solutions, roots, zeros, and x-intercepts are the same exact thing. I will be asking for all of these if you want that extra point. I realize that I can go into my review here, into my key, and go over just a few more questions if you're interested. Here you look at my GCF. The GCF between these two terms is 5. That is all we're doing here. This has v to the 3rd power, and this has v. Oh man, I thought that this was going to let me... Wait, I want my laser pointer back. Give me one moment. Open a new window. Yes, my laser pointer. If we look here, this has v to the 3rd, and this has v to the 1 power, which is a single v. I ask you, which is the lower of the v's? The v to the 3rd or the v to the 1st? You'd be right if you were saying this v. That means that they have only 1 in common. The lowest v value is what we have in common. Brilliant. That's it. We're done. Next. The M method for number 7. I took out a GCF. My GCF is 6 here. Now I have n squared minus 13n plus 36. I have multiplied my a times my c value. I get 36n squared. I made my skeleton, this plus, this parentheses, these parentheses, and I brought down my first n squared and my last part of my trinomial, which is this positive 36. Then I multiplied to get 36n squared for these two numbers, and they also had to add to negative 13, which is my b value here. Brilliant. Then I plug these in to my question and to my parentheses that I've created, and that's all we're doing. And now we just find the GCF of each parentheses, we squish, and we're done. And we're done. That's all. Isn't that crazy? When we're solving, all we're doing is whatever we got factored, we're gonna make them equal to 0. Whatever has a variable. Ooh, super secret note there. It's not super secret. Everybody should be able to make that connection. However, if you haven't, that's pretty huge. When we have a variable, we set them equal to 0. Whatever's in my parentheses with my variable gets also set equal to 0. This is a plus, by the way, which is a little ugly. That's all. Doesn't hurt us, though. If you need help with any of these questions, please just go ahead and refer to the study guide key. I have gone through each of them, and I tried my best to make it as clear as possible. I obviously did not go through each question. As you guys have gotten through my class, you guys no longer need me to hold your hand so viciously. And I hope that comes across with as much love as possible. I've held your hand almost to to a fault here. So for this new quarter, I am only going to show you a couple of them. In the next quarter, I will only be showing you the answer key. I will only be showing you generally the actual answers. I will no longer be showing you as many questions as thought out, as worked through as this. I don't think that that is a justice to you. When you move on from my class, you will be going into bigger and greater and better things where you are expected to be able to learn quickly and adapt quickly and be able to use your own notes and be able to use your own thinking and be able to work backwards from an answer. You can do that because I believe in you. You don't need every little thing to be spelled out for you. Your mind is limitless. We're going back to that. I love it. Anyway, my friends, if you have any questions, comments, or concerns, obviously for you, I will be back. Obviously this is my 6th period who has me as who I'm not there for our review day. If you need anything, I will be back. If you have any questions, I am going to be around for you. See you guys later. Bye.